Hey everyone, it's Josh again. Good to see you all and welcome back to this new video. As some of you might notice, I got a professional lighting going on and very excited to test this new thing out in this new video. That aside, I'm going to be talking about electronegativity in chemistry. It's a topic that comes up quite a lot in Gen Chem and even more so in organic chemistry. So in the meantime, let's get into it. So what is electronegativity? Electronegativity is defined as the ability for atoms to attract electrons to themselves, with elements that are more able to attract electrons being known as being more electronegative. So with electronegativity, there comes certain trends on the periodic table. What I mean by that is that there will be some elements that are more electronegative than others. And typically, this trend tends to go that electronegativity increases from the bottom left to the top right, with fluorine being the most electronegative element on the periodic table. Now, some of you might wonder, why aren't elements like helium the most electronegative? Because technically helium is at the topmost right of the periodic table, and that's a great question. And the reason why is because elements like helium and all of its group mates down below within the same group are actually noble gases. Noble gases are not electronegative at all because they have a full octet and they are completely happy with the electrons that they have. Halogens like fluorine, chlorine, iodide, bromine, those guys, they need one more electron in order to complete their octet. So that's why halogens tend to be very electronegative overall. So we're going to take a closer look at elements like fluorine as well as sodium in order to better understand how is it that their electronegativities are so different, even though they're kind of close to each other in atomic number on the periodic table, with fluorine having an atomic number of 9 and sodium having that of 11. We're also going to take a look at oxygen to see how it compares to fluorine. So I want to make a clear note that fluorine and oxygen are in the same period, whereas fluorine and sodium are located in different periods. Fluorine and oxygen are located in period 2, whereas sodium is located in period 3. So we're going to make comparisons with fluorine and oxygen, both of them being in period 2. So here we note in these little diagrams that oxygen has 8 protons and 8 neutrons. Fluorine has 9 protons and 10 neutrons. So those of you might think, oh yeah, because fluorine has more protons, it's going to attract more electrons to it. And as a matter of fact, that is correct. Fluorine is going to be more electronegative simply because it has more protons. This only applies to elements within the same period, because let's see this other example in which we have elements that are not in the same period, because fluorine and sodium. Fluorine is in period 2, sodium is in period 3. Fluorine, as we established, has 9 protons, 10 neutrons. Sodium has 11 protons and 12 neutrons. That would lead one to think that sodium should be more electronegative because it has more protons, right? Well, not quite. Actually, that is not the case at all. Sodium is far less electronegative than fluorine. And so that really gives us a huge question that we need to answer. The big question is, why is sodium less electronegative than fluorine, even though it has more protons? Because we just established that if you have more protons, you're more able to attract more electrons. So that technically makes you more electronegative up to a certain degree. So what gives? Well, what gives is electron shielding. Electron shielding is going to make all the difference when it comes to electronegativity. Protons are one factor when it comes to electronegativity. The more protons you have, the more electronegative you're going to be. However, electron shielding also plays just as big of a role, if not to some extent even bigger, because electron shielding is going to prevent new electrons from joining in. And I'm going to show an illustration with oxygen and fluorine first. I want to note that fluorine, we established, has more protons than oxygen. However, when it comes to shielding, the two of them only have 2 degrees of shielding. Both oxygen and fluorine have 2 shells of electrons. The first shell contains 2 electrons, and the second shell contains up to 8. In the case of oxygen, it uses 6 of them in order to make a total of 8 electrons. And in fluorine, ends up using 7 of them to make a total of 9 electrons. The outer shell is the valence shell. That's why oxygen has 6 valence electrons and Fluorine always has 7, needing 1 more just to be a noble gas. The point I'm trying to make with these arrows and pointing out the shielding is that oxygen and fluorine actually have very similar degrees of shielding. And because they have similar shielding in that they only have 2 electron shields, as a result, fluorine will end up being the more electronegative one because it has more protons. This is only under the condition that they have the same electron shielding. Now, in the case of fluorine versus sodium, because sodium has 1 more electron, it's going to have 3 shields. It fills up the first 2 shields, and it's going to need the third one to contain that extra electron. And as a result, sodium is not really going to want to keep that extra electron around. The whole point with shielding is that there is repulsion between electrons in different shields. Electrons in shell 1 and shell 2, they're going to repel against each other, as well as electron shell 2 with shell 3. They end up causing a lot of repulsion and a lot of forces that cause them to not want to be around each other. Sodium is going to want to give up 1 electron, whereas fluorine wants to gain 1 more to complete its octet. So because sodium has 2 places where electrons are repelling itself, compared to fluorine, where it only has 1 place where electrons are repelling itself, it's going to be a lot harder for an electron to enter into the third shield because there's already so much electron repulsion going on. At 2 places specifically, between the first and the second shielding, there is repulsion, and between the second and the third levels of shielding, there is also repulsion. Whereas fluorine only has repulsion occurring at 1 shield, between the first and the second levels. So what that means is that fluorine is going to be the more electronegative element compared to sodium. The reason is because it's going to have a stronger attractive force. The more electron shields an atom has, the more its ability to allow new electrons to enter is weakened. That's how it works when it comes to electronegativity, specifically. And that's the reason why fluorine is more electronegative than sodium. So in short, electronegativity is revolving around the attractive forces that atoms have towards outside electrons. And there are 2 factors that influence it. Number 1, number of protons. And number 2, shielding. Electronegativity increases when you have the number of protons increase only up to the extent to where you do not add another shield. Because when you add another electron shield, your ability to gain new electrons goes down. Because electrons always want to follow the noble gas configuration, which is to have a full octet. If they have any more electrons than that, then they will want to give them up. I hope that this video helped clear up electronegativity and all the concepts associated with it. In the meantime, be sure to hit the like button and to subscribe to my channel to find out more chemistry topics. I'm super excited to start this series with you guys and to teach you all I know about chemistry. Hope this helps. I'm Josh, and I'm the Chem Tutor, and I will see you in the next video. Bye.